So I'm Will, this is Tony, and we're going to be sharing tonight with you Icecomm. So Icecomm is a solution for incorporating WebRTC features, all the amazing power of WebRTC, which some of you guys will know about, some of you won't, and we'll go through it a bit, into your app, soon into your mobile app as well. Now, I'm also involved with Codesmith, so I am proud to say we're responsible with this highly intimate setting, but that's also kind of nice. So we'll want to take like a couple of questions. If people have questions during the talk, there'll be questions at the end as well, but feel free. In fact, please throw up your question, get a chance to kind of engage, tackle with what goes on as we go along. Okay? All right. So the guys behind Icecomm, Alex, Tony here, and me. And I will pass over to Tony.
All right, guys. Just first, I want to see how many people have heard of WebRTC? Oh, wow. Nice. Okay, so whenever people are talking about WebRTC, there's two different things that you could be talking about. Either the collection of protocols that are being specified by the IETF and the W3C, or we're talking about the JavaScript web APIs, which is what I'm sure everyone here is interested in. The JavaScript APIs for browsers are now allowing people to connect browser to browser through this new API that is being implemented by Chrome and Firefox at the moment. It seems like IE and Safari will be coming later, but it's not looking good for them as usual. And so the basic idea of WebRTC is we wanted to, or not we, but the IETF and W3C, they wanted to make it, possible to have a reliable, secure, and standardized connection between browsers. So that's what WebRTC does. Although once you make a connection between two browsers, you won't be needing a server. Initially, you will need a signaling server to pass information between the two browsers to tell them things like what is my public IP and how can you reach me. And both of these browsers get this information, and once they input that into the APIs, then they become directly connected, and you can start transferring video and audio between them. And it does take a lot of work to set up, the signaling server, the turn and stun, and then also the browser APIs are not that great to work with, but it is worth it. It ends up being worth it. WebRTC gives you reliable connections. It's secure by default. Every connection that you make with another browser is completely encrypted, and it's serverless connection. So since you are connected browser to browser, it is faster. And that's why we created Icecomm, to make this process easier. And Will is actually going to tell you more about that.
All right, so any questions so far? Go ahead.
Opera also supports it.
Opera.
Oh yeah, my favorite browser till 2009. Sorry. Okay. So we launched at number 2 on Hacker News, which this was a side project to begin with, and so it was a wonderful experience to go out there and get this amazing engagement from our community. We also went out on Reddit, and they gave us a slightly different response. We put together a JS Fiddle demo. Now, our JS Fiddle demo meant that almost every user who came through, and we had 90,000 uniques on our very first day, almost every user who came through clicked through to our demo and joined the largest and most bizarre, curious, not bizarre, chat roulette ever. And I mean, you can see this stuff here. I don't know if anyone can read this. It's a good justification, to be fair. I don't know if I just... We'll let this do the talking, really. This is the power of WebRTC. To be fair, people have also built some pretty amazing things. Someone was talking about Node WebKit. Node WebKit was involved in building Virtual Car. Virtual Car is awesome. So these guys here, they wanted to make their remote workers feel kind of more in the office. So they set up webcams all around the office, which could be controlled by the other members of the video chat. So they were always kind of present, moving around. They're kind of looking at people as they talked in meetings. And this guy, this is just fantastic to see people build it. He built this. My favorite quote, he said, I used Peer.js. It took me 4 or 5 days, still couldn't get it working. Saw this on Hacker News, and in 5 minutes had it set up. So that was really special to us. There's also some code collaboration tools. But let's dig into now. It looks like people don't have their laptops with them, and that's totally fine. So you can just follow along. But if anyone does want to follow along on JS Fiddle, don't all get your laptops out at once. But if anyone does want to, feel free to do so. I'm seeing 2 people move. 3 people. Okay. Someone using an iPad, which is a tragically futile effort. Only because WebRTC doesn't unfortunately work on it. So people are taking photos, so if they do want to use this link, they can start working on it.
You can also find the link on Icecomm.io.
Yeah. This link actually is kind of fun. This is not a fully built out video chat app. The one on Icecomm.io will be the fully built out one, so you can kind of work with this. Okay? All right. So, a little bit small for some people at the back, but we're going to go sort of back and forward a little bit on this so you can keep on top of it. But this is the essential HTML. First piece, you're setting up a video element into which you're going to pass your local webcam stream. Okay? That kind of intuitive. And then you're going to import the Icecomm CDN file. So what we enable people to do with Icecomm is in 8 lines of front-end JavaScript set up a full video chat experience. But we're obviously pulling in, and in fact, some people on Hacker News are like, this is not 8 lines of code. There's thousands of lines of code behind this, which slightly misses the point. But this CDN here, is what where we get that data, we get that code from. Okay, I'm going to pass to Tony at this point.
Okay, so normally with WebRTC, you're gonna have to set up all the offer-answer exchanges, passing of ICE candidates, and all this stuff. With Icecomm, you could just instantiate a new Icecomm object. From there, you'll enter in your API key, and then you'll start setting your event handlers. The first one you might want to set is for local, and this is gonna fire once you accept whenever you tell the browser that you will allow it to use your webcam and your microphone. Then next you're gonna want to if you're building a video chat app, then you're gonna want the remote users connection, and that's where the onConnected event handler fires. Once somebody else enters the room that is not you, then that will fire, and you can take the video or a stream. We actually give you a couple options here. You can either just take the raw stream, or we give you a pre-made video element to input into your HTML. And then you'll want to define the disconnect handler, and probably just remove a video element. And lastly, you will connect to a room, and from there you can specify whether you want audio or you want video or neither, or you can just set up data channels between them.
Okay, so at this point, let's take a breather. I know some people are actually typing this out, and those who aren't, that's cool. But I want to sort of throw it out to questions. So we've laid these pieces out here. It's sort of pretty typical signaling layer on top. But I'm interested in your guys' sort of the things which you're feeling you don't quite know about yet. So all questions are open. Any things you're curious about? Yeah, go ahead, man.
Do you guys automatically break down the WebRTC connection before you remove the element?
It's a great question. Hold on.
The question was, do we break down the WebRTC connection on a disconnect? Yes. So what we do on the back end is we whenever somebody disconnects, since we use a socket IO, we fire off a disconnect function that handles the disconnection for you once a user leaves the room. That's how it works. Any other questions?
Let's say someone inspects your client-side JavaScript, finds the name of your chat rooms. What would prevent them from just crashing in on different kind of chat rooms that they weren't invited to?
Yes. Okay. So so the question is, what if somebody looks at your client-side JavaScript and sees a room name and
They see your room name.
Yeah.
And that make them crash in on.
Yeah, and can that person crash in on that room? Yes, you can. So so what we kind of ask our developers to do is as long as you use those tricks to keep your API key a secret, then you'll be fine, because it is per API key. So whenever you make a room, your API key can't talk to somebody else's API key. Like whatever rooms are established with those API keys, they're completely separated in different domains.
So right here we're building like a one-to-one, peer-to-peer kind of app.
Okay, so we kind of built this from the ground up to be a mesh network, like right out of the box. So this will handle as many remote connections as all the users' computers can handle. So right away, anytime somebody enters a room, then this onConnected will fire. And what we're doing here is we're just appending a new video element to the body. So every time a new person joins, a video element gets appended.
Do you think that new app Meerkat is using WebRTC to do video streaming?
Is Meerkat using WebRTC? They are not. I don't believe.
We can't know for sure, but the big challenge with broadcast is WebRTC is not set up to be one-to-many, really. We are working on something pretty exciting and groundbreaking that's going to make one-to-many far, far lower server load. Yeah, we're going to be sharing that. We're not quite there yet, but it's related to this kind of mesh network idea. So it's a great question. And another one.
Could you run this off a mesh network that's not connected to the internet?
I don't know if I understand the question. Not with WebRTC, I don't think.
Okay, just wondering.
But yeah. Okay, so I mean, if you're following along, you'll hopefully be seeing a little bit of prettifying here with the CSS, but don't worry about that too much. So finally, let's look at some things you can build WebRTC in now. So the idea of contextual communication that emerges when you need it, which WebRTC is very adept at doing, that's maybe a little bit of a way off to truly revolutionize communication in browser. But there are some things you can do right now that are really interesting. In e-commerce, we've got marketplace apps here, education. So e-commerce, contextual audio support. So one of the reasons that audio support, phone calls, it's such a pain in the ass for everybody, both customers who hate going through the multiple screening steps and e-commerce companies who have to pay to have service staff, is that you really only want to have people engage with audio support when they really, really, really need it. Well, one of the powerful things about WebRTC is that you can do that. So you're on a payments page, and the person's been waiting for 25 seconds, and they've got $300 in their checkout basket, and they haven't clicked confirm. You can push an audio call to somebody, and suggest that you'll be able to help them at that moment. So you can actually think of it like the Uber driver who calls you just as you're about to be picked up. Perfect timing. The phone number only exists at that moment. This is the same thing that can happen in an e-commerce situation. So we'll talk about that a bit more maybe, but that's a really interesting use case. Marketplace app, so you'll often see this, people want to move some of their pitching, for example, between clients online. If you want to do that in an app, right now you often put out to a Google Hangout link or to some other plugin. This just makes that user experience so much better. Broadcast content, so in education, this is a big deal. Can you broadcast out with your MOOCs? Can you actually pass to thousands of users potentially without having this very costly server load? Well, one of the things we're building, and it's not there yet, WebRTC doesn't support this, one of the things we're building will enable that broadcast side of WebRTC. So that really brings us to the end of our main discussion, but I'm sure some questions would have emerged from that as well. So go ahead, man.
Are you, with WebRTC, are you actually sending out your screen once for every peer you're connected to?
Yes. In your video? Yes, right now, yes. Yeah. So that's one of the things that is just part of the WebRTC as it stands right now. And the idea is, and the thing we're working on, in a multi-way chat, many to many, that's kind of how it, there's ways of optimizing it, but it's the second best situation to optimize that. In one to many, suddenly it becomes really interesting what you can do with passing streams around. Okay. Further questions? Go ahead. Hey, go ahead.
From what I can tell, the browser asks for permission for the webcam, and then it just basically looks like it just holds on to it. So when you implement this, you end a call, it looks like it's still got the mic. It's not exactly in terms of user experience, it looks a little sketchy when you're sitting there for hours on a page and it's still. So have you run into that at all?
That's a really interesting question. So just to repeat the question, it's about user experience, which is obviously very relevant to our next talk. So once you grab the stream, ultimately it will sit there, you're suggesting, and how can we perhaps define something in our setup that would switch it off after a certain number of minutes or something like that? Is that?
Basically something to give people assurance that their mic isn't being listened to while they're not on the call.
Yeah.
There's no actual connection.
It's a great question.
That's actually one of the reasons that Google pulled their screen sharing support for WebRTC. They pulled that out because of security risks, because they don't want their users to unknowingly be sharing their screen without having some kind of indication. With video and audio, you'll always have that maybe green light that comes on if you have a Mac or whatever it is for whatever computer you're using. But with screen sharing, they're more wary of it because there is no real signal kind of showing that you're still connected and somebody can still see you. And that's kind of why they removed that feature. But yeah, the WebRTC, they put all that on the user, really. Not Hangout. I'm talking about Chrome specifically. They removed that feature.
Related to that, does this work okay with background tabs, like for background windows? So like once you fire it up, video keep working.
Oh, will it the video still be going in the background if you go to another tab?
More importantly, your video is obviously
yes.
Okay, and the audio is still good. Because I know the browsers have gotten really aggressive about background tabs, just shutting down JavaScript, shutting down, slowing down stuff. So
Yeah.
It's still running.
It still runs.
It's more of a question about WebRTC in general. How does it work with both people natted? With both people behind firewalls, like NAT?
Oh yeah. Okay, so
Does it work? It does work, right?
It does. It works with NATs by using stun and turn. If we go to the next slide, actually, stun and turn is what handles these natted systems. The only one that it will not handle is a symmetric NAT, and the reason being is because the first thing WebRTC will do, your client, it will talk to the stun server and say, hey, where am I? What is my public IP and what port am I mapped to? And once it figures that out, then it can tell the other peer and they can get connected. But with a symmetric NAT, it changes every time you make a request, or based on the location of the request that you make. So in symmetric NAT cases, it will have to fail over to a turn server.
And that goes to the server?
Yeah,
Okay.
that gets relayed.
Off of the turn, are you worried that, I mean, I guess symmetric NATs are probably not that common, but are you worried at all that you're going to have a lot of bandwidth usage for the turn servers?
It's an interesting question. I mean, it's an interesting issue. Like, so far, it seems like nobody has a symmetric NAT because we've only paid like 20 cents in turn server usage this whole time, and we've had a lot.
But that being said, it is a piece of the puzzle here that means that WebRTC is a little bit more of a kind of hosted solution than it is a sockets type, no possible fallback. So it's definitely worth being aware of. Supposedly 10% of connections should be turn, but we're not seeing
the corporate side of things, maybe.
Possibly, yeah. I can imagine. Yeah, that makes sense. Question over here.
How did you do signaling on your servers? Do you do WebSockets or?
We use sockets. Yeah. So we use sockets directly. Oh, so I'm sorry. Yeah. So the question was, how do we do signaling? And we use sockets. So, and we also use sockets kind of in a more sort of user experience type way. In terms of developer experience, the design, as you see, is the API design is very similar to sockets. And that's intentional. It's something people know so well, and it's a good guide. Question over here.
What are your plans, or what are the solutions for encrypting the channel?
Yeah, great question. Let me just...
Actually, all WebRTC connections, peer connections, are encrypted by default. It's a built-in security. Like you can't even opt out of it. Actually. Any other questions, guys? All right. Well, thank you.
Thank you so much, guys. This is great. Thank you.